Okay, let us start the class now. And today's topic is electric energy and electric power under current electricity. Okay, and what we are going to cover here will be discuss about electric energy and what is electric power. Then commercial unit of electric energy, and last we will discuss about rating of electrical appliances. Okay. So let us discuss one by one. First is electrical energy. What is electrical energy? Okay, just let us go through it. The conductor offers resistance to flow of current. Okay, so work is done to maintain the current through it. Okay, what this is talking about? Let us suppose one circuit is given here. Okay, this circuit is having one battery on the resistor and one bulb connected in the series. Okay, so what is happening here in this circuit, which contains this conductor as well as this resistor also, it is having its own resistance. When the charge flows, as we know, what is current? The flow of the rate of flow of charge is current. When charge flow means when electron flows, there is opposition to flow of these electrons, we can say, or charge or current. It is opposed by the resistance, but we have to maintain the flow of current in the circuit. It means some work has to be done for maintaining the flow of current in the circuit against resistance, and that work is said to be energy, electric energy. Okay, let's let's denote as I. I means current in flowing in the circuit. Okay, then V means voltage potential difference across the both ends. This is potential difference of the battery. Okay, let's R. R is resistance in the circuit. Okay, so as per the Ohm's law, we have already related that V is equal to I R, right? Okay, so actually what is happening here, because as per this circuit here, electric energy available in the battery. This electric energy, due to flow of current, this bulb is glowing, means the bulb is giving the heat and light. Means what is happening, this electrical energy is converted into heat and light in this case. So we will go through various forms of energy which are existing and how it is converted to other form. Various forms of energy exist, such as mechanical energy, heat energy, chemical energy, electrical energy, light energy, and nuclear energy. Right? We will see that how this energy is converted to other form to meet our requirement. In first case, what is given here? Electric heater and geyser. What is the purpose? Why we are using this heater and geyser? To have some heat energy. So we are providing electric energy to these appliances, and what it is doing, it is just converting electric energy to heat energy. Let us take next example. In case of electric lamp, we have already discussed here how the electric energy is being converted into heat energy. Next, in case of fan, mixie or juicer, we are providing the electric energy, and that is being converted into mechanical energy as per our requirement. Next example, in case of loudspeaker, we are providing electric energy to the system, and sound energy is produced in this case. It means what is happening? Electric energy is converted into sound energy. And next, in and what is done here? One, let us suppose one soft iron bar is here. This is soft iron bar, and around this bar one coil is installed like this. Okay, when electric current, I mean to say electric energy provided in this coil, what happens? This soft iron bar gets magnetized. Means it creates its own magnetic field. Means electric energy is being converted into magnetic energy in this case. So these are some examples where we have seen that how the form of energy is converted from one to another. And most important, okay, most important, energy can neither be created nor destroyed. Very, very important. It can be converted to other form, but it can't be created or it can't be destroyed also. Very important. Now let us see how to measure the electric energy. Okay, let us suppose we'll have one electric circuit. This is resistor. Okay, same way we have connected your bulb in this circuit, and what is happening here? The potential difference across this battery is, let us suppose, V. The resistance of this resistor is R, and current flowing in the circuit is I. This is positive terminal of the battery. This is negative terminal of the battery. So current is flowing from positive terminal to negative terminal like this. Direction will be this in case of conventional current. Okay, fine. So let let potential difference means PD across this battery, across means both ends, across the battery is V. Okay, then we can take current similarly, then charge also, and charge flowing in the circuit. In the circuit, let's suppose it is Q, and for how long this charge is flowing in the circuit, we will take here as T, means total time, total time for which charge is flowing. Charge is flowing. This is T. Okay, and we can take this one. Work done to moving this unit charge from one end to other end. Let's suppose that is W. W means what? This is work done to move unit charge from one end to other. Okay, voltage you have taken, and we have to take I also. I means this is current flowing in this circuit. So how to relate all these terms? Okay, since we know what is potential difference, that is work done per unit charge. So we can write here V is equal to W by Q. We can write. Okay, we can, because we have to relate this W, means W will be equal to V into Q. Okay, we know that what is current. Current is the rate of flow of charge is said to be current. So we can write I is equal to Q by T. This is the rate. So in place of Q, what we can write? Q is equal to I into T. Okay, we'll put this value in this equation. Means W is equal to V into Q. We have already calculated. Then we can write V into I into T. We can write this equation. W is equal to V I T. Okay. As per Ohm's law, we know. Let's move to next page. As per Ohm's law, we know V is equal to IR. So we can put this value in that equation. W, what we written here? W is equal to VIT. Putting the value of V here, we can write IR into I into T. It will come out to be I square RT. Okay. So what we have related here means W is equal to I square RT. What is W? This is the total work done by the current in the circuit. And what we have defined here? What is energy? Energy is also the total work done by current in the circuit. Means this is the energy. Okay, this is energy. So what we have concluded here, key W is depending upon what? What are the factors? Where W means energy depending. It depends upon the current, resistance, and time. Total time for which the current is flowing in the circuit. Okay, means energy. We can write here energy, or that is work. Work, work depends upon the current flowing in the circuit, flowing in the circuit, then resistance of the circuit, and time for which current or charge is flowing in the circuit, for which charge is flowing in the circuit. Okay, so this is the measurement of electric energy. Fine. Now let us move to next. What is electric power? See, what we have studied in case of energy. What is energy? Energy is just, you can say, doing of work by the current in the circuit. Okay. Now electric power means this is the rate of doing work by current in the circuit. This is the difference. It will give at which rate the work is being done by the current in that electric circuit. Okay. So as per definition, we can write here, since we know what work is equal to what? V and Q. We have calculated here, na? V is equal to W by Q. This is the basic formula. The total work done per unit charge by the current is known as potential difference, that is V. So we can calculate W is equal to V Q. And next, as we know, I is equal to rate of flow of charge, Q by T. So we can write here Q equal to I into T. We have seen also earlier. So we can write here V is equal to V I T. W is equal to V I T. We have already calculated here. Okay. Now, what is electric power? What is electric power? It is denoted by P. The rate of doing work means we can say electric power. Okay. P is equal to W by T. This is the rate of doing work. Putting the value of W here, we can write here V I T by T. Okay, this will be cancelled out, means Vi. We can write here P is equal to Vi. Okay, what we have concluded here, what the impression has come up here? Power is equal to voltage multiplied by current in that circuit. Okay, and what is the unit of power? The unit of power is watt. Okay, so let's suppose this P is equal to 1 watt. 1 watt. In voltage we have taken 1 volt, and current we are taking here 1 ampere. 1 ampere. So how we can define? If a potential difference of 1 volt is maintained in the circuit and 1 ampere of current is flowing in that circuit, then it means the power of that circuit is said to be 1 watt. Okay, so here we have already seen 1 volt multiplied by 1 ampere is equal to 1 watt, right? If it is to be converted into kilowatt, what we can do, power in kilowatt, we can say here means of volt, we have to take v in terms of volt will take, then we will take this current I means in ampere, we will take in ampere, okay, and just divide by 1000. It means it will be converted into kilowatt. Okay, further write we can write here that P as per Ohm's law, P equal to VI, okay, and V is equal to, as per Ohm's law, V is equal to IR, V is equal to IR as per Ohm's law. We can write IR in place of V, so IR into I will be equal to I square R. So we can write P is equal to I square R also, or we can one more, in place of I we can write V by R also. So V into this one V by R, so V square by R, okay. So V is equal to P we can write VI, we can write I square R, or this is also the relation V square by R. We can relate all these things as per the requirement. Okay, this is R. This is R, I square R. Okay, so this was all about electric power. Next, let's move. What is commercial unit of electric energy? Okay, commercial unit of electric means what? Okay, all the electric appliances what we are using for our purposes, they are having some rating. Power rating is given on it. Okay, but that is to be calculated on our basis. We can write when an electric appliance okay of power works okay, means how to calculate in terms of hour, because it is to be commercialized. In the terms of commercial, how you can calculate it? Okay, when an electric appliance of power works for 1 hour, let us suppose for 1 hour it is working 1 hour. So how to calculate the commercial unit? So in case of commercial unit, the power is to be calculated in terms of kilowatt hour. Okay, how to convert it? Okay, 1 kilowatt hour means what? 1 kilowatt into 1 hour, 1H we can write like this. 1 kilowatt means what? 1000 watt. Okay, and 1 hour, it is to be converted into second. Because we have to calculate this watt in terms of joule per second. Okay, so we can write 1 hour means what? 60 minutes into this one 60 second. We have converted this into second, right? How much? 6 6 are 36. 36 into 10 to the power 5. This is WS, watt second. Watt second we have written here. Okay, fine. We know W means what? Means watt is equal to joule per second. Okay, it means watt into second is equal to joule. Okay, so we can write here 3.6 into 10 to the power 6. In place of Ws, we can replace it with joule. We can write here joule. Okay, this is 10 to the power 6. Okay, it can be also replaced with mega. So we can write here 3.6 megajoule. Megajoule. We can write like this. Okay, so what we have calculated here, 1 kilowatt hour means 3.6 megajoule. Okay, so how to convert it into again in kilowatt hour? We know W is equal to, we have already calculated, V I T. Okay, so 1 watt hour, what we can write here, means V means 1 volt, 1 ampere we can write, and time 1 hour we have to write here, 1 hour in short. Okay, but we have to calculate it into kilowatt hour. This one energy to W in kilowatt hour will be just divided by 1000, means volt. Potential difference given in volts. Okay, then I will be given as in ampere, and time T will be given in hour, and T will be in hour, and divided by 1000. It will give the result in terms of kilowatt hour. Okay, fine. Next, rating of an electric appliances. See, we might have seen, whenever we go to any shop for purchasing these items, the shopkeeper asks of what rate you are going to purchase the bulb. So we have to tell, okay, we need 10 watt, 9 watt, 15 watt or 100 watt rating of bulb. Means what is it talking about? If you purchase this electric appliances, the rating will be given like this only. Means power as well as voltage. Okay, for example, this is the rating of one bulb. The rating given 100 watt, 250 volt. Okay, it is already mentioned on the bulb. It means what does it show? Okay, rating means what? So we know power is equal to, we are talking about this bulb, which is written over 100 watt, 250 volt. Power means what? We know Vi. Okay, in place of I, what we can write here as per Ohm's law? V into means V by R, because we have to calculate the resistance value of the filament. Okay, so can you write here V square by R? Okay, means what? P is equal to V square by R. Let me write once more here. P is equal to V square by R. So we can write here also R is equal to V square by P. Why I have written like this? Because V is given here of this ball, and this one power is also given 100 watt. 100 watt means what? 100 watt. This is power. This is power of the bulb. So voltage is given 250 volt and power is also given 100 watt. So we can calculate the value of resistance of filament. So let us calculate. In place of V, what we'll write here? 250 square by 100. Okay, just let us do it. 250 into 250 divided by 100. Okay, cut it, just multiply it. It will come out to be 625 ohm. Okay, fine. The resistance of the bulb is 625 ohm, right? We have calculated the resistance. So now we can calculate the range of current also. Means at what value it can sustain the current flow through this filament. Okay, so current through the bulb filament. Bulb filament. How to calculate? Current means I, means V by R as per the Ohm's law. And what is V and what is R? Okay, here power is given of this bulb. Power is rated here na 100. So we can calculate I is equal to P by V also. P by V, because P is given and V is given. We know P is equal to VI. Okay, so we can calculate I is equal to what is P value? P is means 100 divided by voltage 250. Okay, 5 and 2 means 2 by 5 is equal to 0.4 ampere. So I is equal to 0.4 ampere. What does it show? It tells the what is the current capacity which can flow through this filament. At what current, up to what current that filament can sustain. It will be not fused, it will not destroyed. So this is the range for that bulb where the maximum current can flow 0.4 ampere through that bulb. There will be no harm. Means maximum, we can say the maximum current which can flow through this bulb is 0.4 ampere. So how will we come to know? We have gone through the rating of this electric appliances. We have picked up here bulb, and what you have written on the bulb, on that basis we have concluded that maximum 0.4 ampere of current can flow through this circuit. I mean to say through this bulb. Okay, so this was all about the rating of the bulb. Okay, so let us close here. After that, we'll take up some numericals based on these topics. Okay.